Hello everybody. Today is June 22nd, 2022. This is my 7th episode for C++ 17, 20, 23, CUDA, SYCL, OpenGL, OpenCL, TBB. I filmed 6 videos to create Hello Graph. We will learn what is TBB graph, also CUDA graph, SYCL graph. These are on the to-do list. Graph in modern C++ parallel programming revolutionize the way we do parallel programming. If you are endowed the license of free will and watch it, my previous videos listed here, and installed all the required tools properly on your machine, you can now enjoy TBB graph, also CUDA graph, SYCL graph in your daily programming routine. More specifically, we will learn flow graph, also flow control, input node, function node, make edges. I emphasized several times asking you to purchase a copy of ProTBB, this book. ProTBB by James Linders is super good, too good to miss. However, significant part of this book is now deprecated. That doesn't mean ProTBB is worthless. ProTBB is the only book that systematically explains underlying working principle of threading building blocks, also TBB graph. You cannot fail to find how valuable this book is if you once begin to read. I sign in. Amazon says I purchased this book October 29th, 2020. October 29th, 2020. This book was published July 9th, 2019. Actually, this is second purchase. I purchased and read this book in October 29th, 2019. It's all up to you whether you read this book or not. But if you understand TBB graph, you can get CUDA graph and SYCL graph almost for free. Sadly, flow input node is the newer one. In old day, they used flow source node, which is now deprecated. In episode 5, I detailed deprecated or removed in TBB 2020. If you haven't watched this video, I would highly recommend you to watch this video by clicking this link. In this book, ProTBB, considerable amount of this book is dedicated to flow graphs, starting with chapter 3. If you read along this book, you will face lots of frustrations due to deprecated features of Intel TBB. However, if you are following my videos, I pinpoint how to fix your code. Even in Intel's documentation, oneTBB documentation using input node. This definition is now deprecated. It doesn't work. However, I help you how to use this input node correctly, properly. I will post this script. Double-click this link. From this link, download sample code. You need this oneTBB master. Unzip it on your local machine. Rename it 000 oneTBB master. Copy, paste it in your working folder. When you feel frustrated while reading TBB, then you have to consult the source code in this master examples by category. For example, graph, for parallel for each, for pipeline, etc. Also, you need to download the functionality deprecated in TBB 2020 and removed in oneTBB. This PDF details what has been deprecated. TBB flow source. This TBB flow source is now deprecated. Its input node. In this book, whenever you face source node, you have to replace with input node. As I warned you, this documentation is wrong or deprecated. Without further ado, let's get started. Start Visual Studio Code. Open your working folder. Don't show again. No. We will create a new folder. 007. Hello, graph. Click this button. graph.cpp. Hit enter. Ctrl V. Include talk play fun. Output HPP. Namespace TPT. Talk play fun. Types. Please commit this namespace alias TPT into your memory, because we will use this namespace alias all the time. Another one, namespace flow, TBB flow. Talk play fun, S-stream print, oro NL, talk play fun NL. Flush out to console. Oro NL, new line, character. Void test graph basic. I will copy and paste these things. Flow graph. We define G. G is an instance of flow graph. Context per int n 10. Auto inputter, we capture n. We have to capture n even though it is context per, because Microsoft compiler does not allow implicit capturing context per, so we have to capture n. We create state. It is int. We use TBB flow control. It should be L value reference FC. We are going to make changes to state in this lambda. If state less than n, watch it carefully. Return state plus plus. We are modifying state. This is a value inside our lambda function or closure type. We cannot change or modify the state in lambda. We need mutable. We will return int. Because state, we return state. State is int. We return int. Else, we have no more work to do. We iterate only 10 times. So, flow control FC, stop, no more work. This is a function, but we have to return int, so we want to return int. This is for C++ compilers complaints, or make C++ compiler keep silent. This is our inputter. Now, here we create flow input node. We take a template argument, return type of inputter. Inputter's return type is int. This is inputter's return type or output type. I say my source. We pass graph. Then we provide inputter. We are using input node. In this PDF, it is marked as a source node. This source node is now deprecated. Here, flow function node. This is input value, int. This int is this int. We make my node. The first argument is graph. The second is flow unlimited. Don't concern about flow unlimited for the time being. We will discuss it in future sessions. Now we create a lambda int I, or I say auto parallel body. Int I, it does not return. It simply prints out I, then not NL. This NL causes a long journey. Instead, we use NL. Here, we provide parallel body. So we defined function node. Now here we make edge. Flow make edge. The first is my source. So from input node, my source, this source here, to target node, my node, we made an edge. Edge represents data stream flow from source node to target node. Data flows. My source activate. We are instructing my source node, this node. Now using inputter, this inputter produce a stream of data of type int. Once again, we are instructing my source node, hey, come on, produce a stream of integers using inputter. Inputter is defined here. Activate means source node now produce a stream of ints. We have to wait, graph, wait for all operation ends. Please understand, I said this function node, this parallel body, this body executes in parallel. So we have to wait all parallel instances gets completed. Now here we haven't displayed, we just accumulated the result in the print buffer. So we tell print now flush out to console. Int main, we copy test graph basic, paste it here. We will start with clang cd 007 hello graph clang ++. You should use std C++ 17 or 20, at least C++ 17. Graph.cpp, this is the source file. We need LTBB 21. Wow, 21st century. No, not 21. 112. 12. O c.exe. Hit enter. CLS-C. Wow. Now G. We use GNU G. I would copy this. Copy. Paste it here. Also C clang. Now we try with Microsoft. CL EHSC SED C++ 17 graph.cpp TBB 12.lib fe m.exe. Hit enter. cls m. Bingo. Copy. Paste. Now we use NVCC. You should have installed NVCC. dir NVCC std C++17 graph.cpp ltbb 12 on.exe. Hit enter. cls n. Wow. GNU compiler successful. This is GNU compiler. We also need to test data parallel CPP QSDD C++17. Don't forget EHSC. F no SYCL because we don't use SYCL for the time being. graph.cpp or d.exe. In this case, we don't need to specify TBB because this is Intel. CLSD. Bingo. Copy this. Paste it here. Okay. Now scroll down. I would change it into NL and make it bigger. We will build once again. CLSD. You can notice some problems. Also, GNU G++, CLSG, some problems. Because this my node parallel body, this body is executed in parallel. So we need to address this problem. I will copy, paste. It's now better. I will remove this part. Our code is exactly the same. I would use NL. Now, everybody repeat. Spin scoped mutex lock. Spin scoped mutex lock. Spin scoped mutex lock. Spin scoped mutex lock. If you remember spin scoped mutex lock, you are having a very good start to the world of humanity or parallelism. So we know we need synchronization. TBB spin mutex capture by reference. In this block, TBB spin mutex scoped log mutex. We fixed our code. We call this fixed function and paste it here. We build. Once again, we can use any compiler. We will use NVCC, NVIDIA CUDA compiler. CLS N now works perfectly. Microsoft compiler should also work perfectly. Every compilers are happy. Now GNU works perfectly. Perfect. Basically, ProTBB, significant parts of ProTBB are deprecated. However, this book explains Intel TBB systematically. Also, deep insights about how all these things works behind the scene.